So the first lecture here we're going to talk about is fractions. So first I want to talk about what is a fraction. So a fraction is a part of a whole. So we have a fraction, and this is going to be a part of a whole. Now what do I mean by that? I mean, like, so let's say you have a pizza or a pie, kind of the most standard. So I have a whole being the whole pizza or the whole pie. Now you split this up into different sections. So let's say I split it up into 5. So there's my 5 pieces. Now if I want to say 2 pieces of the pie, so I'm going to shade 2 of them here, that would be 2/5. So whole is the bottom number. This is saying how many total slices do you have. 2 is going to be the number of slices that we're looking at. Now what we're going to cover is how to add, subtract, multiply, and divide. But before we do that, we do need to mention mixed fractions. So a mixed fraction means maybe I have 2 and 1/3 pizza. So this thing I have 2 wholes plus a third of another. Now there are a couple ways we can deal with mixed fractions. First, we can leave them as mixed fractions, or we can change them to be improper fractions. Now how do we change them to be improper? Well, we're still going to have that the whole is 3, because we split everything into 3 parts. That's what this means here. So everything is still out of 3. How do we get that top number? You're going to multiply the 3 times the 2, and then you're going to add the 1. So if I multiply, I get 6 plus 1 is 7. So if I'm going to convert mixed fractions into improper fractions, remember this is improper, this one is mixed. You're going to multiply and add, kind of making this little circle pattern. So let's say I want to convert 4 and 1/4. Let's say I want to convert that into an improper fraction. So I'm going to multiply and get 16, add to get 17, and remember it's still out of 4. There's that 4, same one. We're still changing everything to be 4s. Now let's see if we can go the other way. So let's say I have the fraction 10/3. Can I change this to be a mixed fraction? Well, the way we do this is to say, how many whole pieces do we have? Remember, a whole is 3, because we're putting everything in thirds. So how many wholes do I have? Well, I have 3 of them. Right? 9 of those 10 would be 3 wholes. How many do I have left over? Well, I have the 1. And we can double check ourselves. 3 times 3 is 9, plus 1 gives me 10, so 10/3. So again, how did we get that? How many wholes could I take out of 10? I could take out 3 of them. That gave me 9. I had 1 left over, so I got 3 and 1/3. Let's try one more of these. How about 13/4? So 13/4. Let's see. How many wholes do I have? Well, I can go up to 12, and that would give me 3 whole pieces. And how many do I have left over? 1. So 3 and 1/4. And again, double check yourself. 4 times 3 is 12, plus 1 is 13. So yeah, it does check out. Okay, now let's talk about adding. So the first thing we're going to do is adding. And really subtracting. We'll do that at the same time. Oops. So with adding and subtracting, the problem is you need a common denominator. So if I'm talking about pizzas again, let's say that I have 1/2 of a pizza, and I want to add to that 2/3 of a pizza. So what we're trying to do here is 1/2 plus 2/3. Well, in order to get the answer, what you need to do is kind of repiece the pizzas. So instead of having this one being in 2 pieces and this one being in 3, we need to find a common number that we could separate the pizzas in. So one way to do that would be 6. So instead of splitting this left one into 2 pieces, I'm going to split it into 6. Instead of splitting this right one into 3 pieces, I'm going to split it into 6. Now rewrite these fractions. So on the left here, how many pieces do I have shaded? Well, I have 3 of the 6. And we'll talk about a different way to get that in just a second. Over here, how many do I have? Let's see, I shaded 1, 2, 3, 4 of the 6. Now add them together. Again, everything's still out of 6. I had 3 and then 4, so 7. You could leave it as improper, that's fine, or rewrite this as mixed. You'd have 1 whole and then 1 6 left over. Now an alternate way to do this. Okay, so alternate way down here. I have 1/2 plus 2/3. Think of a number that both 2 and 3 go into. Well, 6. 6 is a number that both of them go into. Now ask yourself the question, 2 times what gave me 6? So 2 times what number gave me that one? The answer is 3, so I got to multiply the top by 3. 3 times 1 is 3. Now how did I get that? You got to multiply the top and the bottom by the same thing. Because really, any number, write it over here, any number, let's say, I don't know, 11 over 11, that's the same as 1. Any number over itself is just 1. You're allowed to multiply by 1. That's fine. That's not going to change your problem any. So I can multiply this fraction by 3 over 3. Now come to this next fraction. What do I want to multiply that by to get a 6 on the bottom? Well, I want to multiply it by 2 over 2. So the first one I multiplied it by 3 over 3, now 2 over 2. So I get a 4. Do the same thing as before. I get 7, 6, which is 1 and 1, 6. So that's adding. We've got to find the same denominator, add along the top, keep the bottom. Now let's do an example of subtraction. So let's say that I have, how about 5 6 minus 1/2. I don't have the same denominator, so what I need to do is convert everything. So think of a number that both 2 and 6 go into. Now there are lots of choices. I could choose 6, I could choose 12, 18, all those work. I'm going to go with the easiest one, 6. Now for the first fraction I haven't done anything, it's still a 5. Now what about the second fraction? I multiplied the bottom times 3, so I got to multiply the top times 3. Got to multiply them by the same thing. So I get 3 6. Keep the bottom, right? Those are just telling you how many pieces we split it into. I had 5 slices out of 6, I had 3 slices out of 6, and I subtracted them. How many slices do I have left? Well, 2 out of 6. Now I want to be a little bit careful here. 2 out of 6 can be reduced because they share a factor. Both of them share a factor of 2. So I'm going to divide both by 2 and get 1/3. Again, how did I get that? Divide both of them by 2. So there's subtraction. Now let's talk about multiplication. So the nice part about multiplication is it's easier than addition and subtraction. You think that because it's multiplying it's going to be more complicated, but it's actually not. All you have to do is just multiply straight across. So let's say I'm doing 1/2 times 2/3. Do I need a common denominator? No. That's only for addition and subtraction. So I'm going to multiply straight across, and I get 2 6. And we know from above that's equal to 1/3. Okay, what about 4 7ths times 1/8? Let's see, multiply straight across, I get 4 out of 56. Now comes a time where we need our times tables. Can I reduce this? So is there a factor that goes into both? Well, yeah, 4 does, but let's say you didn't see that. Let's say you only saw that they were both even. So divide both by 2. So when I divide that by 2, what do I get? 28? Well, 2 goes into both of those again, so I get 1/14. So that's multiplication, just multiply straight across. Now let me make this a little bit more complicated. 2 1/3 times 4 1/5. How am I going to multiply those? Well, what did we do before? We converted everything from mixed fraction to an improper fraction. That's what we want to do here. So I'm going to convert everything. So the first one, it's going to be out of thirds. I'm going to multiply and add to get 7. Look at the second one. I'm going to multiply and add to get 21. And now what do? We have fractions just like before. I'm going to multiply straight across. So 21 times 7. Let's see, maybe we need to do that over to the side. So I got a 7 and 14, so 147. And I think this one's fine to just leave as is. No need to convert that to a mixed fraction. Probably complicated enough. So if you have mixed fractions and you need to multiply, or add or subtract for that matter, convert them to improper and then do what we've been doing. It's just one extra step, but it's the same thing. Now lastly, we need to talk about division. So division of fractions, not that different from multiplication. Now here's why. If I tell you to take the number of dollars, or however much money you have in your pocket, take the amount of money you have in your pocket and divide it by 2. That's exactly the same as multiplying by 1/2. So division by 2 is equal to multiplication by 1/2. They're exactly the same thing. Division and multiplication are in fact very, very similar. You might have been lied to your whole life. It's just multiplication by the reciprocal. So instead of division by 2, multiplication by 1/2. So what about division by, let's say, 3? What do you think that's going to be? So if I say take the amount of money you have divided by 3, that's the same as multiplying all the money you have by 1/3. So how do we divide fractions? What you're going to do is you're going to take the second fraction, you're going to flip it, and then multiply. Because, as we just said, multiplication and division are the same. Division by something is the same as multiplication by its reciprocal. So let's use some examples. How about 2/5 divided by, how about 1/3? Division by 1/3 is the same as multiplying by 3/1, or just 3. Go straight across, 6/5. And if we want to convert this to be 1 1/5, that's fine too. Okay, what about 1 1/6 divided by 2/5? Well, here we run into that problem again where I don't have just a standard fraction or an improper fraction here. I have it mixed, so let's convert it. So 6 times 1 is 6, plus 1 is 7. So I got 7/6 divided by 2/5. Dividing by 2/5, exactly the same as multiplying by 5/2. Multiply straight across, so I get 35/12. I don't think we have any common factors there, so I'm going to leave it as is. If you want to, you could convert this to mixed. How many times does 12 go into 36? Well, I think just 2, and then you have 11 left over. Again, that part's a little bit extra, but it's okay. So there you have it. You have adding, subtracting, multiplication, and division by fractions.